Imagine walking into a factory the size of several football fields, where millions of tiny particles, sheets of glass, and microscopic circuits come together to form something you probably take for granted: your TV screen. That glowing rectangle in your living room isn't just plastic and glass. It's the product of one of the most complex manufacturing processes humans have ever engineered. And today, I'm taking you behind the scenes of how those massive television displays are made, step by step, from raw materials to the dazzling screens that light up living rooms all over the world. First, let's step back a moment. Television itself has been around for nearly a century, but the way we make screens has changed dramatically. Early TVs used bulky cathode ray tubes that weighed as much as a small fridge. You had a giant box sitting in your living room, spitting out fuzzy black and white pictures. Fast forward to today, and we've got razor-thin screens, curved displays, OLED panels that make colors pop like never before, and massive 100-inch walls of pure cinema you can hang on your wall. But what's mind-blowing is the scale. Factories today can churn out millions of these panels every year, with precision measured in microns, thinner than a human hair. So where does the journey begin? Believe it or not, it starts with sand. Yep, plain old sand. The backbone of any TV display is glass, and glass is mostly silica, which comes straight from sand. Of course, we're not talking about beach sand you'd scoop into a bucket. Factories use ultra-pure silica, melted down at temperatures hotter than lava, to form flawless sheets of glass. These sheets are the canvas on which the magic happens. Now picture this. A single sheet of mother glass can be as big as a garage door. From that one sheet, manufacturers cut multiple TV screens. The size depends on demand. Want to make smaller 32-inch screens? You can slice dozens out of one. Giant 75-inch monsters? You'll get fewer, but the process is the same. This is one reason factories look like sci-fi clean rooms. Dust, even a single speck, can ruin an entire sheet worth thousands of dollars. Workers wear head-to-toe clean suits, and machines do most of the heavy lifting. Once the glass sheets are ready, the next step is coating them with layers thinner than spider silk. This is where we enter the world of semiconductors and nanotechnology. Every modern screen, whether LCD, LED, or OLED, relies on controlling light at a microscopic level. So factories deposit layers of materials like indium tin oxide, which is transparent and conductive. Think of it like wiring that you can't see, a hidden grid that will eventually tell each pixel when to glow. And speaking of pixels, this is where things get really fascinating. Your TV might say 4K resolution, which means it has about 8 million pixels. Each pixel is made of subpixels: red, green, and blue. When combined, they produce the rainbow of colors you see on screen. Manufacturing those pixels isn't like painting dots on a canvas. It's done with photolithography, a process borrowed from computer chip making. Imagine shining ultraviolet light through a stencil to etch patterns on the glass at microscopic scales. That's how the factory builds the millions of tiny switches that control each pixel. But let's not get lost in the science. The real marvel is the choreography of the production line. While one machine coats glass, another is layering circuits. While one robot slices glass sheets, another is aligning them with liquid crystals or organic compounds. The line never sleeps. Giant conveyor belts move panels from one stage to the next, and precision robots work 24/7. Human workers supervise, maintain, and test, but the actual assembly is a ballet of machinery. At this point in the process, if you peeked at the glass, it wouldn't look like a TV yet. Just thin sheets with weird patterns and coatings. That's because the magic of display comes later, when backlighting and color filters are added. In an LCD screen, for example, liquid crystals are sandwiched between two sheets of glass. These crystals don't produce light on their own. they bend it. To make them work, factories add a backlight, usually made of LEDs. Imagine shining a flashlight through Venetian blinds. The blinds tilt to let different amounts of light through. That's what liquid crystals do, except on a microscopic scale. For OLED screens, the process is even wilder. Instead of using crystals to bend light, OLEDs produce their own. Factories coat the glass with organic compounds that emit red, green, or blue light when electricity passes through. This means no bulky backlight, deeper blacks, and insanely vivid colors. But it also means manufacturing is more delicate. One speck of dust, one slight misalignment, and the whole panel can fail. That's why OLED factories are some of the cleanest places on Earth. Now, here's a detail most people don't think about. Every single pixel has to be wired, millions of them. Each one is like a tiny light bulb that needs its own switch. That's where thin film transistors, or TFTs, come in. Factories build a matrix of these transistors right onto the glass. They're invisible to the eye, but absolutely critical. Without them, you couldn't control which pixels turn on or off. Imagine trying to light up Times Square if all the neon signs were hardwired together. You'd never get a clear image. TFTs are the solution. And just when you think the process can't get any more intense, here comes the testing phase. Factories can't afford to ship panels that have dead pixels or uneven lighting. So every screen is hooked up to diagnostic machines that blast test patterns across the display. Black, white, red, green, blue. These solid colors reveal imperfections. A single dead pixel can mean rejecting the panel or reworking it. Multiply that across millions of units, and you start to appreciate the precision required. But we're not done yet. Because building a TV screen isn't just about making pixels glow. You also need durability. After all, you're going to touch it, move it, maybe even bang it, while mounting it on a wall. Factories stress test screens with bending machines, vibration tables, even thermal chambers that blast them with extreme heat and cold. The idea is to simulate years of wear in just a few hours. If a screen survives, it graduates to the next phase. And that's where we'll pause for now, because so far, we've only covered the raw glass, the microscopic circuits, and the basics of how pixels come to life. In part 2, we'll dive into the real spectacle, the assembly of millions of these panels on factory lines, how different technologies like LCD and OLED diverge, how giant screens the size of a living room wall are built, and the final shipping process that gets your TV from a clean room in Asia to your Netflix binge in the living room. When we left off, we had raw sheets of glass, layers of circuits, millions of pixels wired up, and the foundations of a television display. But here's the thing. You still couldn't sit down and watch a movie on it yet. A screen by itself is fragile, incomplete, and honestly kind of boring. To become the glowing centerpiece of your living room, it has to go through the final stages of assembly and processing inside those massive factories. Now picture this, an assembly line longer than a city block. Robots slide panels from one stage to the next with the delicacy of a surgeon, while forklifts haul in crates of components like backlights, bezels, and driver chips. It looks like chaos, but it's anything but. Every step is timed to the second, because when you're producing millions of TV screens a year, even a few seconds of inefficiency adds up to huge losses. One of the first major steps in final assembly is pairing the display panel with its backlighting system. For LCD and LED TVs, this is crucial because the liquid crystal layer itself can't make light. Factories mount rows of LED diodes, sometimes on the edges of the screen, sometimes behind it in full arrays. The LEDs are then paired with diffusion sheets that spread the light evenly, so you don't end up with bright spots or shadows. It's kind of like turning a flashlight into a floodlight, uniform, smooth, and consistent. OLED panels, though, skip this step entirely. Remember, those organic compounds glow on their own when electricity passes through. That's why OLED screens can get so incredibly thin, sometimes just a few millimeters, but that thinness comes at a cost. Handling them in factories is a nightmare. Imagine trying to move a sheet of tissue paper the size of your living room wall without bending or tearing it. That's why OLED manufacturing lines often use vacuum suction machines and robotic arms that never shake, even by a hair. Next comes the driver circuits. These are the little brains that tell each pixel what to do. If pixels are tiny light bulbs, driver circuits are the switches. They're bonded to the panel using techniques like chip-on-glass or tape-automated bonding. Sounds fancy? But think of it like fusing a microscopic control board right onto the screen. Without this step, your TV wouldn't know how to display a picture. It would just be a blank glow. By this stage, the display finally starts to resemble a television. Workers or robots attach it to protective frames, add the bezels around the edges, and install connection ports. HDMI slots, USB ports, power supplies, they all have to fit into a housing that's sleek, lightweight, and durable. This is one of the biggest engineering challenges. Consumers want thinner TVs every year, yet the electronics inside, power boards, processors, speakers, still take up space. Factories have to design around that, shaving off millimeters wherever possible without sacrificing strength. Now let's zoom out. You might think making a single TV is impressive, but remember, factories aren't making one. They're making millions. Picture thousands of panels lined up on conveyor belts, each one going through identical steps, each one handled by robots and machines designed for insane precision. In a single day, a factory can pump out tens of thousands of displays. Multiply that by the dozens of factories across Asia, South Korea, China, Taiwan, Vietnam, and you begin to understand the scale. We're talking hundreds of millions of TV screens shipped worldwide every year. And they're not all the same. Different technologies require different tweaks in the assembly line. LCD panels need color filters placed on top of the liquid crystal layer. OLED panels need organic layers deposited in vacuum chambers, a process so delicate that even a single dust particle can ruin an entire run. QLED screens, quantum dot LEDs, use microscopic semiconductor crystals that glow when hit by light, producing richer colors. In those factories, giant inkjet-style printers literally spray quantum dot materials onto the panel. It's high-tech meets art. But here's a question. How do you know if all those millions of pixels are working? That's where quality control comes in, and trust me, it's brutal. Panels go into testing bays where computers flash solid colors, red, green, blue, white, black, across the screen. This reveals stuck or dead pixels, uneven brightness, or weird color shifts. Any panel that doesn't pass gets pulled out. Sometimes they're repaired, sometimes they're scrapped. And because consumers are unforgiving, nobody wants a $1,500 TV with a single dead pixel. Factories aim for near perfection. And it's not just about the picture. TVs also have to survive real-world abuse. Drop tests simulate what happens if your delivery guy isn't careful. Vibration tables mimic the shaking of cargo ships and trucks. Thermal chambers blast them with freezing cold and searing heat to make sure they won't fail in different climates. Some factories even run stress tests for hundreds of hours, leaving the screen on non-stop to ensure no early burnouts. When a TV passes all these trials, it finally earns the right to leave the factory floor. Workers package them in protective foam and cardboard, then load them into shipping containers. And here's another jaw-dropping fact. The logistics are just as massive as the manufacturing. Cargo ships carry tens of thousands of TVs at a time. Warehouses the size of stadiums hold stacks of boxes waiting to be delivered. By the time a TV shows up at your local store, it has traveled thousands of miles, passed through ports, customs, and distribution centers, all without a single crack in the glass. Think about the scale for a moment. The average person might buy 1 or 2 TVS every few years, but globally, we buy over 200 million TVs annually. That means hundreds of millions of panels being cut, layered, assembled, tested, and shipped every single year. The factories behind this are like modern cathedrals of technology, clean rooms the size of neighborhoods, filled with robotic arms, conveyor belts, and laser-guided precision. It's not just manufacturing, it's choreography on a global scale. And it doesn't stop here. Technology keeps evolving. Mini LEDs are pushing LCDs to new levels of brightness. Micro LEDs, tiny LEDs smaller than a grain of salt, promise perfect contrast and color without the burn-in risks of OLED. Some companies are even experimenting with rollable or transparent displays, bending glass and light into shapes we never thought possible, which means, in just a few years, the process I've described will already look old-fashioned compared to what's next. But here's what I love about it. Every TV, no matter how futuristic, still starts with the same humble building blocks, glass, light, and a whole lot of human ingenuity. From sand melted into flawless sheets, to pixels smaller than dust specks, to robots assembling millions of panels with zero room for error. It's a miracle of modern industry. And next time you're binging a show, watching a game, or plugging in your console, just remember, that glowing screen in front of you is more than entertainment. It's the result of a global ballet of science, engineering, and logistics. So the next time you switch on your TV and marvel at the colors, the clarity, or just the sheer size of it, take a moment to think about the hidden journey it made, from a speck of sand to a massive factory floor to your living room wall. It's easy to forget the complexity because the end product looks so simple. But behind that simplicity lies one of the most advanced manufacturing processes on the planet. And if you've made it this far, I want to hear from you. What surprised you most about the way TV screens are made? Was it the sand-to-glass story, the mind-bending pixel engineering, or the sheer global scale of moving millions of displays around the world? Drop your thoughts in the comments. And while you're at it, give this video a thumbs up, subscribe for more deep dives into the everyday tech we take for granted, and stay tuned, because the next story might just change the way you see the screen you're watching right now.